Speaking of scientists, we have one rock star guest who is joining me today. We have Gal Sarid, who is currently a senior research scientist at NASA Goddard Space Flight Center. Gal, first of all, I just wanted to thank you so much for taking time out of your very busy schedule to talk with me today. How are you doing today?
I'm doing great, thank you.
Awesome. Glad to hear it. And I think as we can all agree, it is a great day at SSAI. Am I correct?
Oh, definitely, definitely.
Awesome. Great to hear it. Well, Gal, what I wanted to do during this podcast episode was I wanted to ask you a couple of questions in regards to your current work that you do at SSAI. I think our audience will very much enjoy our conversation today. So my first question I wanted to ask you was, could you please tell the audience about yourself and describe the projects you have worked on at SSAI?
Right. So I am a physics, astrophysics, earth science trained scientist. I did all my degrees back in Israel, where I'm from, and then took a bit of a roundabout route to get to where I am today, going through some stints in astrobiology with NASA's Astrobiology Institute, doing a bit of shock physics work about impacts in the solar system, looking at different observations, looking at how to develop missions and instruments for those missions, and sort of eventually kind of winding my way back to looking into deep space, looking towards Earth at SSAI, where we mostly look at the data coming off of satellites like Terra, like Aqua, like the satellites in the JPSS program, where we are responsible for monitoring the health of these instruments, monitoring the accuracy of the data that we get, and sort of generally producing higher level products from raw data into something that the scientific community, NASA scientists, NOAA scientists can use when they look at weather and general hazards on Earth.
Wow, that's very fascinating, Gal. I appreciate you highlighting about your experiences. And I didn't know originally you had some of your educational experiences in Israel. That's very cool to hear as well. So I really appreciate you diving deeper into those subjects that you got involved in and some of the work that you currently do right now. So I think we can all agree it's not a straight path, from point A to point B.
No, never.
No, there's many different zigzags to get to where you want to go. So, but that's definitely awesome to hear. And Gal, my next question I wanted to ask you was, as a senior research scientist currently supporting calibration and analysis within the MODIS and VIIRS Characterization Support Teams, you are at the forefront of turning raw satellite data into actionable insights for ocean, land, and atmospheric studies. Can you walk us through what that process looks like on a day-to-day basis and how SSAI's technical capabilities play a role in helping NOAA and NASA solve critical challenges like monitoring, environmental forecasting, and even data accuracy across the JPSS program?
Right. So these are actually two questions, right? So sort of on a day-to-day basis, what I do and a lot of my colleagues in the team, we go from looking at more kind of detailed spot checks of the data and looking at different indicators from the satellites, from the spacecraft themselves, of the health of the instrument and the health of the pipeline of the data coming in. From time to time, it could be weekly, it could be monthly, it could be every several months. We go through a process where we produce these reference frames, lookup tables that help calibrate the raw data and turn it into a radiometrically accurate, geolocated, and physically meaningful products that NASA, NOAA, and the general scientific community can use. So we would go anywhere between running automated tools and checking their outputs, looking at the plots, looking at the statistics of different matrix, to actually going into codes, going into scripts, writing and developing algorithms that help us do our work more accurate, quicker, and maybe even do it in a more innovative way where we can kind of pull out new insights from our calibration work and from monitoring work. That's kind of on a day-to-day basis most of what we do. in terms of how SSAI's capabilities contribute to the mission for NASA and the mission for NOAA and the general scientific community. We should remember that all this data is accessible to scientists everywhere. So it's not just NASA, not just NOAA. Everyone can actually access this data and use it, and they do. There are lots of teams that use it all around the world. And so SSAI has a strong background and a strong expertise and a strong kind of approach towards enhance the accuracy of the data and enhance the connection between what we see on the spacecraft, what we see on Earth, and what we analyze from the trends in the data. So we use onboard calibrators, which are different instruments and different parts of instruments that tell us about the health and the accuracy of the data that the spacecraft itself grabs. We have measurements of Earth, signals from Earth, measurements from Earth that help us calibrate and measure and compare these things. And we have our own analysis tools that we developed and that we incorporated from other sources, like NASA, for example, which we use then to develop higher level statistics, higher level data analysis tools that kind of bring these together, both the trending, the comparison of the data, outliers in the data, things that are weird, things that we expect, but we don't see, things that we see, but we never expected. And we have to find a way to explain them and make them consistent with previous measurements, with what we see today, and what we predict to be happening in the future. That's kind of a general view of this.
Wow, that's very fascinating, Gal, and I appreciate you breaking it down even further in terms of your work and specifically how SSAI's technical capabilities play an important role here. So I think it's great, number one, that this data is accessible everywhere, and it's great that in terms of this data that people can see and understand. How is it going to benefit them? What is the purpose behind seeing this data? Those are some questions that we always have to ask ourselves.
Exactly.
In order to make sure that everybody understands and is interested in the content. So
I would just add, it's not just that we should ask ourselves, we have to, we're mandated. We're being employed, we're being paid, we're being looked after in order to do this mission for other people, for other entities. So it's not just that we should do it, but we have to do it.
Yeah, absolutely. And Gal, I was going to say, I think that was very well said. Yes, that is definitely a mandate that we should, do something like that. Because, if you think about it, any generation can, get involved in learning about these cool key aspects, in STEM. And especially with all the data points that I'm sure, come in, trying to organize it all, we definitely want to have some cool, innovative strategies and techniques involved. So, and you and your team are currently doing that. So again, I really appreciate you helping to break that down even further. And Gal, my next question I wanted to ask you was, you recently gave a fascinating presentation titled Small Bodies, Big Impact, highlighting the importance of studying comets and asteroids. And at the same time, as you mentioned a little bit, you play a role within the instrument support group for the JPSS program, supporting MODIS and VIIRS calibration and analysis for Earth observations. How do these two areas of research, specifically planetary science and Earth science, intersect in your work? And again, how does SSAI's expertise help bridge these disciplines to solve challenges like improving data accuracy, understanding planetary processes, and supporting NOAA and NASA's broader mission?
Right, it's a great question. Again, it's a two-part question. So in its most basic form, Earth is a planet. So it is our environment, but it is a planet. So the best way to learn about our planet is to dig deep, either inside the planet or on its atmosphere or oceans, but also to try and understand its context. So we have to learn about things outside of Earth, other planets, other planetary environments, and what they can tell us about the different material and different processes that were involved in the, back in the early history of Earth, in the early history of the solar system. That tells us a lot about how the Earth is constructed today. It tells us a lot about what is going to happen to us in the future. We can see different parts in the solar system, different environments, different surfaces, different planets, which can sort of guide us towards what is going to happen to us, whether it is a large impact of an asteroid coming, hurtling towards us, whether it is atmospheric escape, a change in the atmospheric composition, whether it is the change in the magnetic field of the Earth. All of these play into the level of habitability and, our fate that is tied very, very intimately into the habitability of Earth. We are still unable to live off Earth, so we still have to understand how we can better control our system and better predict it in order to kind of safeguard our future, safeguard the next generations. That's kind of where I see Earth science and planetary science coming in together. Another aspect of that is that I might be biased because I've been doing this for a very, very long time, but I think planetary systems are the most complex in terms of their physics and chemistry. I honestly think that a rock that is going through a wet environment or through wind erosion is probably one of the most challenging systems to model in terms of its physical and chemistry evolution. Way more than stars and large stars or black holes. No worry, I've had that conversation many times. And so understanding these systems that seem to be simple but are actually very complex and have a lot of inputs and outputs in terms of their energy, in terms of their interaction with other parts of the environment. Understanding that is vital in order to develop our understanding of complex systems. And Earth is one of the more complex systems that we know of. It involves living organisms, it involves dynamic environments like oceans, like atmospheres, like Earth's core, Earth's mantle. And all of these interact. So in order to understand such a complex system, we have to understand higher level complex physical systems. And the way to do that is learn of what is out there and try to understand environments that are somewhat similar, but different and comparable to ours. Now, the good thing is that SSAI has a really great mix of high-level scientists, high-level analysts, high-level engineers, and data scientists. So that is kind of the approach of being both pragmatic, because we have to solve problems that are there, right? We have to make sure that our satellite can identify fires in Europe, for example, or dust clouds coming off of the Mojave Desert. We have to be able to solve that problem. But we also interested in having these systems be clear to us in their most basic form. So how does the data that we measure, turn from one thing to another, from raw data into semi-calibrated data, into fully calibrated data, into a scientific product? And that kind of guides us to this understanding of how complex systems, physical, chemical, and in our work, data-driven systems, are intertwined and how they influence different parts. And so in a group, for example, an instrument support group, we have to understand how the different wavelengths work in order to understand how our instruments, MODIS or VIIRS, for example, give us a coherent look of Earth from visible to near infrared, thermal bands in the far IR. All of this has to come together, and SSI has this kind of good mix of both kind of basic understanding. It's not simple understanding, it's basic understanding of the science, but also acute and robust practical application of that.
Wow, Gal, you brought up some excellent points in relation to your work and then also what SSAI is doing. So it's just absolutely incredible. I, again, appreciate you breaking that down. And it's, I think as we can all agree, it's very fascinating to see like how Earth has evolved over the last, tens of thousands of years, if not, several millions of years, because there's still some things about, planet Earth and even out in space that we just don't yet know about quite yet. So it's very cool about these wonders and these phenomena it definitely gets us, asking questions. And I think definitely at SSAI, we definitely like to think outside the box. We dream big and we think of, how we can be successful with something. So that definitely, enables us to go even farther. So, and it also helps to keep our engagement up and for our external audience as well.
Exactly.
Gal, like I said, I really appreciate you helping to break that down. And Gal, my final question I wanted to ask you was, and this is a fun question, just as a side note, but the question is, if you could take one capability from MODIS or VIIRS and use it to study any planet or even an asteroid in our solar system, which one would you choose, and what would you hope to discover?
It's a great question. I'll just preface it by saying that, I mean, I've been involved in several missions, deep space missions that were aimed at looking at asteroids and comets, developing the mission concept itself and developing different instruments in that mission. And I can tell you that it is hard. It is really, really hard when you start breaking it down and seeing how far am I from the sun? What can I get? What can I measure off that surface? How can I grab that molecule and understand what it's doing? What kind of reflected light, a photon hitting the surface and coming right into my instrument, what is it going to tell me? And how small does my instrument have to be? How much power is it going to use? How much data can I actually send back to Earth? How much do I have to process on board that spacecraft? These are all questions that become very, very involved and complicated as you start developing these ideas. And so what I would love to have is to have that breadth of capability in the spectral and imaging approaches that MODIS and VIIRS have, both that breadth in observing from visible out to far infrared, and the robustness of the data. And so if I were able to take an instrument like MODIS or VIIRS, make sure it survives and operates long enough. Side note, MODIS has been active on 2 satellites, Aqua and Terra, that have both been working well past their lifetime. They've been out there for 20, 25 years. It's well past their lifetime, and they're the engine of the scientific community in terms of weather. So very, very robust, excellent instruments. I would take these, and I would be so happy to be able to put these on an orbit around an asteroid, or kind of whizzing through a comet as it kind of turns and starts spewing out gas and dust, or maybe even looking at one of the moons of Saturn or Jupiter, because then in one fell swoop, in one swath, I would get knowledge about the visible light reflectance, about the infrared that tells me about how material is interacting, the far infrared, which tells me about how the material grabs on to heat and releases heat. It tells me a lot about its underlying structure. So having all of that in one fell swoop, in one instrument, in one robust instrument that I know works, and I know has a long, long history of well-calibrated, well-validated data, it would be just a boon for a mission that goes out there. But it's hard. Most of the instruments that go on these deep space missions are highly, highly capable, but you have to break down what you want to get. Do you want a camera that's focused on imaging the visible? Do you want a hyperspectral instrument that is focused on some narrower wavelength range? You have to pick and choose because you don't have the space, the volume, the funds, the power to drive everything. So I would just love to take MODIS or VIIRS and kind of, as they are, maybe slightly enhance their sensitivity, because we are going further away from the sun and we will go to fainter objects, and just use them and hope, cross my fingers, hope they will live, a fraction of the time that MODIS has been active out there and the time that we expect VIIRS to be active through the JPSS program.
Wow, I was going to say, Gal, you brought up a lot of interesting facts that I didn't really know about, and you brought up some great points in
Mhm.
relation to that question. So I appreciate you highlighting some of your expertise even further, and even some of your ideas as well. And for those of you who are currently listening to our podcast episode right now, we definitely will be providing a couple of links for you all to check out even further. So please definitely click on the links below in the YouTube description of this video, so that way you can learn more about what Gal is doing, and also some of the great work him and his team are working on right now. And please let us know any questions or comments that you might have. We're very excited to engage with all of you. And with that, Gal, like I said, I just wanted to thank you again so much for
Great.
taking time out of your very busy schedule to talk with me today. You are truly a rock star who is really making an impact and a difference globally, and everybody around the world is going to continue to be fascinated by the great work that you and your team are currently doing. Please definitely keep us posted about some continued insights and some important discoveries that come later
Sure.
on in the future, and we cannot wait to highlight it.
Sure. Great.